Today we're looking at 2.4 kind of, but not really. We're supposed to be learning about inequalities in this chapter, and so I think that now is a good time to go ahead and introduce that stuff. Today what we're going to do is spend time learning how other symbols integrate with the skills that we've already learned. There are two types of symbols, ones that are consistent. We've seen the equal sign, we've never seen it change. There is also a symbol that says not equals, that's an equal sign with a slash through it, which we really won't use, but I figure you might as well see it because it is one of those consistent symbols. And then you have four changeable symbols, which is greater than or equal to, less than or equal to. The difference between those is that whenever you take an equal sign and you flip it over, it still looks like an equal sign. Again, I can't really show you because I wasn't really all the way prepared, but if you were to take an equal sign and turn it this way, it's still going to look like an equal sign. Whereas if you turn these symbols over, they don't point to the right anymore, they point to the left. If you turn these over, they don't point to the left anymore, they point to the right. So that's why they're changeable, is because if you flip them over on themselves, then they actually change directions. The tough part of working with changeable symbols is just learning exactly when to change them. Every time I start teaching this, I have kids just flipping signs like crazy, and you're not even supposed to touch them in 90-something% of the situations you're in. So just remember, when we're using modeling and we had a negative variable or upside down cup, and I told you that if you had an upside down cup with, let's say, 3 pluses, that you had to flip over those cups and make that to 3 negatives. Well, anytime you are switching signs, these parts, then that middle sign would also switch. So again, the truth is the sign changes when you switch signs. The reason that it did not change is because we had an equal sign in the middle, and you notice that an equal sign is consistent. But whenever you switch your negatives with one of these signs, you're going to have to want to be careful, because if you don't, things are going to mess up. So again, for those of you who like to divide by -5, now is where you might want to consider making a change, because this is where things get funny. So what I taught you last week was that if you have -5x equals 25, to turn this into a positive 5x equals -25. And again, the sign stayed the same because equals is a consistent sign. Then you divide both sides by 5, getting x equals -5, and that was right. Over here, what you have to remember is if you change that 5x to be positive, you must also flip the sign around and turn the side. So there's actually 3 changes going on every time you change a sign. The only difference is that changes, but it still looks the same. And then when you divide by 5 here, you end up with x is less than -5. So again, notice the signs here and the signs there are different, but the only reason they changed is because I had to switch that -5 to become a positive 5. The difference between the two types of symbols is that the changeable symbols will always change when signs are switched. Another situation that is encountered is when the variable is on what we would call the wrong side of the problem. So considering the examples, if I had 8 equals x and I don't want the x on the right side of here, then what I would do is bring my x over, put down my equals, and write my 8, and it would be the same as x equals 8, which is why some of you asked me, is it okay if I write it this way? I said yes, because again, equal sign is a consistent symbol, so it does not change. That will not work here, because if you notice, the symbol is pointing at the 8. So if I bring my x over here and put my 8 over there, my sign should still be pointing at the same number that it was, which means it needs to flip over and point at the 8. So again, keep in mind, if you switch signs, so if I turn it from a negative x to a positive x, the sign switches. That's what my last example showed. And if you switch sides, it also does as well. You might want to write these examples so you have a reference when you go onto your Math Excel. But again, looking at these questions here, some situations you're going to see, which is the main situations you're going to see. -8h equals 184. Again, once I see a negative number attached to a variable, what I would do if I were you is switch everything, which includes a sign, and then work it out using a positive number. Now again, for those of you who like to divide by a -8, just make sure when you divide or multiply by a negative number that you do it the right way. -184 divided by 8 is -23. So h is less than or equal to -23, and that would be your answer. Now if you were going to graph that, that greater than or equal to would actually be a closed circle, and that symbol actually points to the right, and so that's what tells you where to go. But again, you'll get some practice with that. -240 equals 15t. Again, the t is over here with 15, So we divide by 15. Notice I didn't switch anything, so nothing major happens. Negative 240 divided by 15 is negative 16. And again, what you will notice is that the sign does not change because I didn't do anything with a switch. But now that t is on the wrong side, I need to bring it over here. And so in order to do that, I have to make sure the sign switches with it. Again, if you were going to graph that, the negative 16 would be here. It would be a closed circle. And because it's pointing to the right, this would go off to the right. But again, notice my first step, the sign didn't change. There's only two times when you change, when you're switching signs or switching sides. Here, C, the first thing I would do is my 14 is negative, so I'm going to switch everything by making this 266. Because I am switching, that changes, and the 14 becomes positive. Now I divide by 14, which is not a switchable step. It's just division. So it's 266 divided by 14, which is 19. The problem is f is now on the wrong side, so what I'm going to do is bring the f over, bring the 19 over, and since this is pointing at f, I want to make sure it's still pointing at f as I turn it around. Alright. So again, the work today isn't really that bad. It's just going to be mistakes made on your signs, which we want to get done today, or get over today, so that we can have them under control whenever our quizzes come up. Outside of switching sides or switching signs, the symbol does not change. Overall, the work does not change either. So if we were working out this problem, we have a 9 on the bottom. We multiply both sides by 9. We bring down 2x minus 3. Notice the sign doesn't change. We bring down 27. We add 3 to both sides. That cancels. 2x comes down. Notice again, the sign doesn't change. We bring down 30. When dividing by 2, that is not a major shift. We just end up with x is less than 15. And again, notice the sign does not change unless I am switching signs or switching sides. And that is the main thing you need to know. When you go to work out a problem like this, and I bring my 2x over here by subtracting it the way we were taught, notice the sign didn't change. I move my 3 by subtracting 3. Notice again, the sign does not change. When I divide by 6, again, the sign is not going to change, and that is the main idea. So the reason that we didn't really learn, or the reason I didn't introduce it, is because there's really only two situations where the signs come into play. And again, it's when you're switching signs or switching sides. So just keep in mind your new steps, or your steps will not change. The only time that new information comes into play is if you have a negative attached to the variable, or if you have the variable on the wrong side, which would be on the right side of your equation. Use the rest of the hour to learn how to incorporate the new information. Be sure to work hard and ask as many questions as necessary. And again, that's why I sit at my desk, is so you can come and find me. Or if I walk around and I'm around, make sure you ask for it. But again, just make sure you're working to learn it. Good luck.